In this lab, we will continue with the time series data analysis of the public transport network data around Auckland. In the past lab, we looked at the trend growth plot, and it looked like somewhat this. So this line from 2005 to 2020 shows the pre-COVID, and then after that these are the forecast. So there is upper limit forecast, lower limit forecast, and the forecast, and this is made with the trend data. So we looked at the trend data, and we made the we plotted. So yeah, so this middle line shows the forecast value, this upper line shows the upper limit, and this lower line shows the lower limit, and these are the forecasted values, and they are shaded in between. And this line here, this is the actual pre-COVID data. Now in this lab, we will add the monthly seasonality pattern to the predicted growth, and we will plot the actual data for pre-COVID and post-COVID, that is for trend plus seasonal component. So the pre-COVID data looks like this. It has a seasonal column, the trend column, the residual column, and seasonal plus trend plus residual gave us some child column, and there are actual values column. So we get the last available seasonal pattern from the pre-COVID period. So last 12 months for monthly data. Let seasonal pattern equal pre-COVID column seasonal dot tail 12. So it will and dot values. This will read the last 12 values of the seasonal column from the pre-COVID data. So we can see that yeah, so the very last data is from 1st of February 2020. So it will read the 12 values upward, and that is equal to seasonal pattern. Now we will apply the seasonal pattern to the post-COVID forecast. So let forecast with seasonal in the post-COVID data frame equal forecast column in the post-COVID data frame. So in a way we are copying the forecast column in the post-COVID data frame to the new column forecast with seasonal. And then apply the seasonal pattern to the post-COVID forecast. So let the upper limit with seasonal equal to post-COVID upper limit. So we are copying the upper limit column to the new column upper limit with seasonal in the same data frame post-COVID. And then we will copy the lower limit column to the new lower limit with seasonal column in the post-COVID data frame. So seasonal pattern is this, the last 12 values from the pre-COVID data frame. Apply the seasonal pattern to the post-COVID forecast. for I in range of length of post-COVID. So the length of post-COVID is the number of rows, and which are 29 rows. So the range will be from 0 to 28, and I for I in range, so that will give us I equal to 0 from 0 to 28. Let monthly seasonal value equal seasonal pattern bracket I mod length of seasonal pattern. Now length of seasonal pattern, these are the 12 values. So length of seasonal pattern is 12. I in the range 0 to 28 mod 12. So it will the I values will divide by 12, and then the remainder will be the result of mode. So the remainder, so for example, if I equal 13, so 13 mod 12 is 1, and seasonal pattern of 1 is minus 266.81450938. So we'll see that all the values will be listed first. So all the values, all the 12 values will be listed, and then remember the first value is for I equals 0. Now, and this last value, this minus 85.2653 so on, is for I value equal 11. Now when I value equal 12, then I mod length of seasonal pattern will give 0. So the array will start again, and it will end at minus 85.2653, and this is when I value is equal to 23. So when I value is equal to 24, then I mod length of seasonal pattern will give us 0, and seasonal pattern of 0 is 1314.99, and then it will begin again, and then we need 5 values. So okay, so that is what monthly seasonal value calculation is. So post-COVID.head open and close bracket prints the first first 5 lines, and it looks like this. And apply the seasonal pattern to the post-COVID forecast. Let count equal -1. For I, row in post-COVID dot iteros, open and close bracket, and then the colon. Now for I will be the index. So the index of post-COVID. So I will be the index, and row will be the columns. And the columns are passengers in thousands, forecast, upper limit, lower limit, forecast with seasonal, upper limit with seasonal, lower limit with seasonal. Count, let count equal count plus 1. So the first value of count will be 0. Let monthly seasonal value equals seasonal pattern of square bracket count mod length of seasonal pattern. Then let post-COVID location square bracket I forecast with seasonal. Now location. Now in the post-COVID data frame, the location is the index, a row equal index, and row heading equal index, and column heading equal forecast with seasonal, and that equals to row of forecast with seasonal. So the row which gives all the column values, we will choose forecast with seasonal, and then we will add monthly seasonal value. And we will do the same for upper limit with seasonal. So post-COVID dot location log square bracket I is for the index, the row index, comma, upper limit with seasonal, that's the column name, equal row of upper limit with seasonal plus monthly seasonal value. Then post-COVID dot log square bracket I comma I is the index, row index name. So comma lower limit with seasonal, that's the column name, equal row of lower limit with seasonal. So we will choose the row lower limit with seasonal from row plus monthly seasonal value. Print post COVID, and this is what it looks like. And with the forecast with seasonal, you can see that it is increased now because the monthly seasonal value is added to the forecast. And upper limit with seasonal, the upper limit is increased by monthly seasonal value, and same with lower limit, it is increased by monthly seasonal value. Now we create the plot. So create the plot. Let fig comma x equal plt dot subplots of fixed size equal width 15, height 5. Plot the trend pre and post COVID. X dot plot of pre-COVID trend, comma k. I'll just show you what happens. Let's create a new cell above and let's plot all this, paste all this, and so now let fig comma x equal plt dot subplots of fixed size equal width 15 and height equal 5. That gives the empty plot. Now so so x in this plot, in this empty plot, we will plot x dot plot of pre-COVID trend, comma, and k is the style of the line, comma, lw equal, this is the line width, equals 0.5, and that gives the pre-COVID trend line. And then we will plot x dot plot of post-COVID square bracket upper limit with seasonal, comma. So we are plotting upper limit with seasonal column from the post-COVID data frame, and the style of the line is k minus k dash dash, comma, line width equals 0.5. So this is what it looks like. So that's upper limit with seasonal. So X dot plot post COVID of forecast with seasonal, comma, style of the line is K dash dash, comma, line width equal 1.5. So, so we are plotting forecast with seasonal from post COVID. Let's run that. And line width equal 1.5. So this bit darker line shows forecast with seasonal. Then we will plot the lower limit with seasonal. So X dot plot of post COVID square bracket lower limit with seasonal, comma K dash dash, comma line width equals 0.5. So we can see that is plotted on there. Let's color that with something different. Color equal say green. Okay, let's see what it looks like. So we can see that it's it's almost it's a very less difference between the forecast with seasonal line and the lower limit with seasonal line. Okay, we'll remove the color equal green. We can say color equal K. K is the color actually, and also the style of line. Yeah. Then we fill between the upper and lower limits of the post-COVID data. So let's do that. So X dot fill underscore between of post-COVID square bracket lower limit with seasonal dot index. So post-COVID, this is the index that we are looking. Index is the row index. So for these are the X values. So which are these values here. And post-COVID lower limit with seasonal, and then post-COVID upper limit with seasonal. So in between these two, it will be filled, and the color will be K, and alpha equal 0.5. So let's see what it does. So that colors the region between the lower limit and the upper limit. Then plot the actual data, trend plus seasonal for both periods. So X dot plot pre-COVID of actual values, comma, color is beam dash, comma, line width equal to, comma, label equal actual pre-COVID. So let's see what it does. So it plots the actual data. So So this the black line that was plotted is for the trend, and the blue line that is plotted now is for the actual values from the pre-COVID data, and the color is B dash, and line width is 2, and the label is actual from pre-COVID. So now let's add x dot plot of post-COVID, and we want passengers in thousands data. So these are from the post-COVID data, and these are the passengers in thousands actual value. And comma, color is R minus, comma, line width equal 2, comma, label equal actual of post-COVID. So the actual data is this, the red one. So we can see that the forecast is aligning with the pre-COVID data. It is more consistent than the actual data. Then we add labels and title. X dot set underscore title of passenger trips across the Auckland Transport Network. X dot set underscore Y label of passengers in thousands. Add a legend. X dot legend open and close bracket. PLT dot show open and close bracket. And when we run that, we get this. So the blue line is the actual pre-COVID data, and the red one is the actual post-COVID data, and these lines over here, these are the forecasted forecast with seasonal. So comparing the forecast with seasonal, comparing the two plots, the previous plot was only with the trend, which is over here. So both of them looks okay. Both of them are very similar. But the confidence interval, the confidence interval region for trend data is quite wide, and for when we do for trend and the seasonal data, then it's quite narrow. And so we will continue in the next lab.